In this video, we're going to look at an exam question where we have to calculate a confidence interval for the mean. Now, the first thing to know is we're taking the mean. We're looking at the mean of 95 bags. We're not given any information about the actual distribution of the weight of these bags, but there is a result in statistics called the Central Limit Theorem that says that by the Central Limit Theorem, CLT, that says that our mean has the distribution n, so the normal distribution, mu sigma squared over n, when n is large enough, when n is sufficiently large. Well, in our example, we've got 95 bags, so n is 95, which is indeed sufficiently large. So even though we know nothing else about the distribution of mass of these bags, the Central Limit Theorem, does apply. So this result holds. The mean weight has a normal distribution with mean mu and variance sigma squared over n. And if we use this result, then the CI, the confidence interval for the mean, is given by x bar plus or minus z s over root n. Okay, so x bar is the sample mean and s is the sample standard deviation. And this really is the formula that we're going to use throughout this question. I'll put a little red box around it because this is the key formula. The only thing we haven't really talked about is what z is, but we'll do that when we actually answer the question. So let's have a look at part I. So we have to work out a 95% confidence interval. Well, as we already know, the CI is x bar. Well, x bar was our sample mean. So let's just write this down. X bar plus or minus z s over root n. Well, that's equal to 498.6 plus or minus z s. That's our sample standard deviation. If you look at the question, that's 9.3. And divided by root n. Well, n was the number of samples, so it's all divided by root 95. Okay. So here's the formula we're going to use. We just need to know what these z values are. Well, these z values, I'm going to copy this table down, come from sort of the percentage points of the normal distribution. So we just need to look at this a sec. We're asked for a 95% confidence interval. So that means that a 95% confidence interval, well, if we look at the normal distribution, looks like this. Well, then a confidence interval is sort of this middle bit. And if we want it 95, we want the middle bit to be 95%. So that means that this side here is going to be 2.5%, and this side here is going to be 2.5% as well, because it's symmetrical. So for a 95% confidence interval, we need what's called the Z 2.5 number. And if you look at this table, if we look at P equals, I suppose 2.5% is P is 0.025 is 2.5%. So the Z value we're going to use for this question is 1.96. So in our question, we're going to have 498.6 plus or minus, we're going to use our Z value of 1.96 from our critical value table. And we're going to multiply that by 9.3 over square root of 95. And that gives us 498.6 plus or minus 1.87, I think. and if you do the minus of that, you get 496.7, and if you do the plus sign, you get 500.5. So that's our 95% confidence interval for the mean. We were also asked in part 2 for the 80% confidence interval, so that's going to be pretty similar. The 80% confidence interval is, again, it's going to be 498.6 plus or minus z times s over root n. But now z, for the 80% confidence interval, well, the sort of formula, again, we can do the diagram before, but the formula is 1, well, requires, it's the 1 minus 80% over 2 p-value. So 1 minus 0.8 over 2. I put the division sign incorrectly. 1 minus 0.8 all over 2. So that's 0.2 over 2 equals 0.1. So we're going to look at the 0.1 p-value. So 0.1 p-value, if you look further up, I'm going to circle it again. That's 0.1 p-value. So that gives z equals 1.2816 from our table. So our 80% CI is 498.6 plus or minus 1.2816 times 9.3 over root 95. And if you do the plus, you get 499.8. And if you do the minus, you get 497.4. And you know, a lower confidence interval will give a tighter range, so that makes sense that this range is a lot smaller than in part 1, the 95% confidence interval. The actual table that we got the z values from, depending on your formula booklet, there's lots of different forms of the table, so you just need to be familiar with what form your specific formula booklet gives these z values in.